All right, let's play one more example, and then when we finish, I'll talk a little bit about how you might want to check your answer with textbook work. So, by now I hope this is straightforward. We're given this information and we're asked to construct a 95% confidence interval. The nice thing about this is really there's only one way to state this question. It's not tricky, it's not challenging. Construct a 95% confidence interval. All right? I suppose one way to ask the question slightly differently, it could say this: construct a confidence interval with alpha 0.05. This could be done. No one ever really does it this way, although I suppose in principle it could be. This is not the most common way to do this. Typically it's construct a 95% confidence interval. It should be clear that these two wordings are equivalent. 95% confident means alpha is 0.05. In any event, so we're going to construct a 95% confidence interval with this given information. So we have degrees of freedom are 50 minus 1 is we are in the 49 degrees of freedom row. We have our value for alpha is 0.05. Alpha divided by 2 is 0.025. So we have our column and our degrees of freedom row. So from these two, we can compute T subscript alpha over 2. We are in the 0.025 degrees of freedom row. And we're in the, degrees of freedom is 49. And our column is the 0.025. I have 0.025. And we need to be in the 49, count them, 49 degrees of freedom row. So I have 49 degrees of freedom, 0.025. My number at the intersection there is 2.010. 2.010. This should now be straightforward. So we have x bar plus or minus t alpha divided by 2 times s square root of n. Formula is given, degrees of freedom is given. We've already computed that to be 49. And so the rest of this is straightforward, I think. We have x bar is given to be 66.7 plus or minus, we just computed that as 2.010. Multiplied by s is given to be 18.1. If that's not given, then this problem cannot be done. This is all straightforward. We need the square root of, in this case, 50. And so we have 66.7 plus or minus, and take my calculator out. And this says 2.010 times 18.1 divided by the square root of 50. And I have 0.0157, so I'm going to approximate that as 0.016. That's close enough for our work. I'm going to approximate that to 0.016. So, for anything I ask of you, this is the way I typically will state my values. This is my confidence intervals. This is the way I would typically state my solutions. However, remember what's happening here, and this is really another reason why I want to go through this third example. What we have here is 66.7, and then this is the margin of error. If you're asked only to find the margin of error, then you don't need this piece. This is the margin of error. This is the point estimate. And that aroma you have is a multiple choice question. So this is called the point estimate. This is called the margin of error. And what that means is we have added that. So we have added 0.016, or minus, we have subtracted that 0.016. Now, we should be able to compute this number on the number line. It is 66.7 plus 0.016. Let's see what I have. I have 66.7 plus 0.016. Well, that's not too hard to figure. That is 66.716 minus, that's 66.7 minus 0.016, and that gives me 66.684. This is an interval of the number line, just like your glory days way back in basic algebra. And so recall, if this is 10 and this is 15, then you may write this as the interval from 10 to 15. This is an interval notation. We may do the same thing here. In fact, the textbook will typically not write this. The textbook will translate into this and writes this as 66.684, comma, 66.716. The textbook will typically write this. I typically write my results this way. I don't care which one of those you pick. I will usually use this. This is the simplest. This is the first one you find. Just put a box around it like you're proud of it and be done with it. Back away slowly. Don't make eye contact. If you start picking at it, then you're going to start to make a mistake here and there. So what I would say is when you get here, stop. Leave well enough alone. If, and this is a big if, and this is for our purposes, the only reason you would need to do this, if you want to check your result against the textbook, then you would need to do this computation. This is what our text has if you want to check with the textbook. This is what I will use in my solutions and my answers when I ask of you. So for my purposes and for example, exam purposes, leave your result like this. If you want to check against the text, you would need to do this solution. So there we go. That's example number 3.